Hi guys, today we are going to focus on finding the equation of an inverse. So a quick overview. If f is a one-to-one function, that is the key. It can't just be a function, it has to be one-to-one. If f is a one-to-one function, how do we find the inverse? To find the inverse, we just reverse all the ordered pairs in f. So if we have function f and if a, b is in f, then to find the inverse, we are going to reverse the orders and that will give us b, a. So if we have that in the back, if we have this in the back of our mind, then we're going to go ahead find the inverse. So I know you can read this, but I'd rather talk to you. So the one and only fun problem reads, consider the one-to-one function f of x. We want to find f funny symbol x. So again, we have to have a clear understanding of what we are being asked to find in order for us to have a fair shot. So we have f, that is the symbol for inverse, so we have f inverse, so we have function notation, so this reads find f inverse of x. Okay, some books may just write f inverse, so just check your book, but they're both asking you to find the inverse. So let's go ahead, take this one step at a time. So to find the inverse of a one-to-one function f of x, so good thing they told us that it's one-to-one, so we don't have to verify it is, we just take their word for it. How can we find it? So it says replace f of x with y. So pretty much what we want to do, we want to get out of function notation. So that's how we're going to replace f of x with y. So far so good. Now bear in mind, to find the inverse, we're just going to reverse all the ordered pairs. So what are we going to do? We are going to switch places. Okay, we are going to reverse the ordered place by interchanging x and y. So wherever we have a x, we're going to replace it with y, and wherever we have the y, we're going to replace it with x. So we have y, which we're swapping out for x, equals x, which we're swapping out for y, minus 3 over x, which we're swapping out for y. So again, to find the inverse of a one-to-one function f, first thing, get out of function notation, replace f of x with y, and then we're going to trade places, interchange x and y, and then we're going to go ahead solve for y. So let's do this. To get rid of the fraction, to get rid of the times y, let's go ahead multiply both sides by y. Sorry about that. And then that will give us yx or xy, depending on how you feel it. Yx or xy gives us quotient of y in itself gives us what? That will leave us with y minus 3. Okay, what do we do thereafter? I think I jumped the gun and I forgot to say it. So after we switch places, we're going to go ahead solve for y. Okay, yeah, I didn't say it, but now I said it. So if we're going to solve for y, we want y terms on one side, left side or right side is a personal choice. We want y terms on one side and then non-y terms on the other. With your permission, let's go ahead subtract y from both sides. So if we subtract y from both sides, then that will leave us yx minus y equals negative 3. So at this point, I'm pretty pumped that we have y's on one side, non-y's on the other. Now, my next goal is to go ahead isolate the y term. But I know that you know that yx and y are not like terms, so I really can't combine them. But what we're going to do, we're going to go ahead factor it from the expression. So if we factor out a y, that will leave us with yx over y is x, negative y over y is negative 1. Cool. And this is pretty neat because now we have a fighting chance to get the y by itself. So let's do this. To get rid of the times y, let's go ahead divide both sides. Sorry, to get rid of the times x minus 1, let's go ahead divide both sides by x minus 1. And I'm running out of space, so let me go ahead and make a new column. Quotient of x minus 1 in itself gives us 0, or we say it cancels out. And that will leave us with y equals whatever we're left with. Negative 3 over x minus 1. Cool. So moral of the story, how do we find the equation of the inverse function? So 1, get out of function notation. 2, everybody trades places, interchange x and y. 3, we're going to solve for y. And then 4, let's go ahead put this in with the proper notation. So in this case, y represents the inverse. Now, most of the time, I know we nailed the algebra, else you would have helped me. But the question is, I need to know, is this one-to-one? Okay, hopefully it is. And if it isn't, it's an easy fix. We'll just restrict the domain. So let me just speak to myself on paper. Let me put verify if it's 121. This is the accepted abbreviation for 121 1-1. How are we gonna verify? Are we gonna do it by hand? Of course not. We're gonna use a calculator. Okay, so let me speak to myself. Use a calculator. Alright, so let's go ahead enter. We're going to enter y equals -3 divided by x minus 1. So we have -3 divided by, the denominator has more than one term, so please go ahead, wrap up the denominator. The worst thing you can do to yourself is get the algebra right, but misinterpret your results because of technicalities. So let's go ahead and graph it and see if this bad boy is 1-1. So again, to determine if a graph is 1-1, we use the horizontal line test. So let me go ahead, bust out my horizontal line. You know, my special effects, that's how we do it. And then we're going to take our horizontal line, slide it once, and make sure it doesn't touch the graph in no more than one place at any given time. And it looks like it did pass the horizontal line test with flying colors. So let me just go ahead and do a quick sketch, because this is how I take a screenshot. So it's something like this. Something like this. I tried my best. Okay, yeah, I shouldn't have taken a screenshot. Okay, so verify if it's 1-1. Yes, it is. Cool. So because it is, we don't have to restrict the domain. But don't worry, in another example in the video to come, I'll show you something where we do the algebra right, but unfortunately the inverse is not 1-1, so we have to work our magic to restrict the domain. Thanks, guys.